Every year, technology evolves. Things are getting smaller and smaller, quicker and quicker, and easier to use. And it is a time for this to evolve. Well, not my phone exactly, but more what's inside a computer.
Computers themselves consist from a great variety of components, but probably the most important one is a microchip. It's the thing that does all the computations in your device. Microchips themselves consist from transistors, and to understand how all this works, we'll need to cover up some basics. What is a transistor? Well, basically, transistor is a switch that blocks or opens path for electrons, kinda like 0 and 1 in a binary code, when 0 is off and 1 is on. Well, those switches from logic gates, which do all the computation and all the calculations in your computer. Well, is there a problem? Unfortunately, yes, and a big one. You see, Moore's law basically states that transistors will get smaller and smaller every year. When we'll reach the size of an atom, we can't do anything. But why? Well, that's because of quantum mechanics, and it's some weird and hard properties of it. Now we're gonna talk about the effect that we call quantum tunneling. Well, let's think about it. If we imagine someone trying to pass through the wall with guards on it, he won't be able to do that. But in quantum world, tunneling will allow instant change of position, like teleportation. So when transistor size of an atom will try to block electron's path, electron will just teleport away. Does this mean a nano of computers? Well, not exactly. It took a lot of science and thinking, and we realized that we can use the same quantum mechanics that stops us to create a new, better type of computer, just with the use of some sort of quantum magic. Let's take a closer look. We took something that we call a spin of a particle. Well, basically the way particle spins. The spin of electron could be either upwards or downwards. Let's pick two colors on a cube, say green and red. And let's say red is 1 and green is 0. Due to the uncertainty principle, if we do not measure the state of an object, that will mean that it can stay in all states at the same time. In our case, electron could have a spin upwards and downwards at the same time. And it's gonna look like this. So that's the main advantage of quantum computer. Wait, so what do we get from all this weird stuff? This means that we can create a new type of computer with different logic, therefore unaffected with this quantum weirdness. Uncertainty principle helps us to understand the superposition. It is when the particle doesn't have a defined position. For example, 2 bits could be in 1 of 4 states at the given moment of time, while 2 qubits could be in any of them at once. The number of values will be 2n, where n is the number of qubits. This solution gives us power, which means we're smart. It is important to know that you gain not the speed but the reduction of calculations you need to make. Use quantum computer in search engines, in robotics, which will allow us to basically make something new that we never done before. Well, it also can be used in some complex calculations. Where this technology could take us, we don't know yet, but we can find an answer.